Hello class, let's see one more question from your September 2019 paper of IFOA. It's a very good question. What it says, a company offer a life insurance policy that pays a lump sum of 1 lakh on the death of an employee before age 60. The death benefit is payable at the end of the year of death. In addition, an annuity of 5,000 per annum is paid to the nominated dependent of the life assured. The first annuity payment is made at the same time as the lump sum of death benefit and continues annually, ceasing when the dependent reaches age 60. Right? So it estimate the mortality experience of its employee by using the table we are given. Let me show you the table. Class, this is my male and female table given to us. Calculate for a life. Male is 35 exact. As a life assured with the female life age 30 exact, the dependent using the mortality table provided an interest rate 5%. Now expected present value of lump sum benefit. So class first is the lump sum benefit of 1 lakh. So that means it is a term assurance class. So class we have sum assured of 1 lakh, life age 35 is there, term assurance is there, and benefit is given maximum till 60. So class if you expand this, what do you get? That is 1 lakh VQ35 plus V square P35 Q36 plus V cube 2P35 Q37 and so on. Last will be V25 24P35 Q59 class. So class, this is what we require for the first lump sum benefit for a male life, right? So class, that means see Q हमें given है, we have to find P first of all, and we have to find 2P35. So what is 2P35? So that is 35P35 into 36. Similarly, this means what? P35 into P36 into so on P your 59. Sorry, 58, not 59. Fine. So in this way, we can find the 1 lakh term assurance benefit. So class, let's make a table first. So class, first let's write the sum assured death benefit is 1 lakh. Annuity benefit is class 5,000, right? Then class, my interest rate is given as 5%. We can find V, discounting factor, 1 divided by 1 plus I, right class? So let's give a name range. This is my S, this is my annuity benefit A, this is my V discount factor, we'll make it V only, fine. So now class, let's start with the first let me write the age, male age, 35, the policy starts, plus 1 and till 60 we are having this. Fine. So class, let me write the QX part first, mortality. So QXM I am writing class, because for it is male and 35 is there. So this is my Q35, right? And bring till 59, not 60 even, because at 60 the policy is expire. So class, we are finding PXM, that is 1 minus your QXM. Fine class. Now class, we have to write, this is my first is 1. If you remember, The formula says we require the p value is 1, right? Then we require p35. So next is p35. So this is my p35 into the above one, and so on. This will goes on till fine class. Now class, we need to find present value of benefit. Class, present value benefit is what? Sum assured into V, right? So if I multiply this above to V, we get V square, and so on. Fine class, make it comma, remove the decimal places. Then class EPB of benefit. So class, how to find a EPB of benefit? So class, present value of benefit into the probability of survival into the probability of death, right? Now controlled, control down and alt up, control down, alt equal to class. So class, this is your answer. 5698 is your EPV of term assurance. Fine. Class, next part is we have to find the expected present value of dependent annuity benefit as well. So class, dependent annuity is 5,000 given on the same point when the person dies. So class, let's see how to find that annuity benefit. Class, first scenario, a life age X die between 35 to 36, right? So if life die between 35 to 36, that means the annuity Y will get from age 31. Current age is 30. In the next year, it become 31. From 31, the female will start getting an annuity of 5,000. So what is class present value? The present value is 5,000 V P30 female. Female is alive and the male must die. Q35 male. Any problem with this? So class, if X die between 36 to 37, if suppose X die between 35 to 36 to 37, then the annuity start from 37, right? So class, plus what? 5,000 V square. That means the first year male is alive, P35 male, and die between 36 to 37. And for the next 2 years, the male, a female must be alive. But class, there must be one more scenario. This is one case if X die between 36 to 37. If suppose X die within the first year, अगर X first year में die भी कर चुका है तब भी तो इसको annuity मिलने वाली है, right? तो class, there is another scenario, class. If Q35 male die within the first year and female is alive for 2 years, then also the 5,000 is given. Yes or no? So class, we can take 5,000 V square 2P30 female common. We left with what? Q35. One is this. Ki either male die in the second year or male die within the first year, right? So class, this scenario, this can be written as what? 2Q35 male, right? And we can find this value by 1 minus 2P35 male. Fine class. Similarly class, X may die between 37 to 38. So one scenario is this. If live die between 36 to 37, then also he will get a benefit. And if male die between 35 to 36, still the person get the annuity between 37 to 38. So the expression become 5000 V cube 1 minus 3p55 male, sorry, 35 male into 3p30 female. So class, what is the meaning of this? This means this is 3q35 male, which means male may die in the first year, male may survive first year and died in the second year, or male may survive 2 years and died in the third year. Clear class? Any problem with this stuff? And this will goes on. Plus, we stuck with one scenario. See the benefit, they said the benefit is given till y becomes 60. So y becomes 60, that time the age of x is what? 65, right? But in the question it is said x must die between 35 to 60, then only these benefit is given. So remember, for the when x becomes 60, y is 55, after that the probability of y will not change, right? So you have to write here 1 minus 25 p 35 male. It will not change for scenario from 60 to 65. Reason being, the person age x can die between 35 to 60 only. Fine. So hope you understood this formula. Now let's do this mathematically. So we need class, we have already find out the TPX in our formula, right? And we need to find the female one. We have to find PY, 1 PY, 2 PY, and 30 PY for female. Fine. Chal. Let's do in Excel. So class, we have given female age is 30. So plus 1 and Q59 for female 59 we have to write. Now so class, first we have to find PX. So PX is 1 minus QX and female age 30. This is my QX. Subtract that. Control down. Now we have to find TPX. For TPX, the first thing is as it is. For the second one, this multiplied by this, right? And fine class. So we get till this. Now class, so class we need a discounting factor also. First let's find the discounting factor. So for the first year we have V. For the next year we have V into V, and till last we have to take, let's increase the number of decimal here, at least 5 digits. Fine. Now class, let's find the EPV. So class, EPV of annuity benefit. So class, first we have annuity benefit amount A, 5,000 rupees, into plus 1 minus the probability of male survival into the survival of female into class discounting factor. Fine. So class, we get this. Now select this till 54. Okay. Control down. The class for this part. Now see my J31 is now class for this cell. What we have to do? See class, for this I told you we have to multiply by 1 minus, see, so class, if you check the formula, we need 1 minus 25p35, right? We need this formula. But when you check in Excel, this formula which we got is 24px. This is 24p35. So we need the 25p, right? So let's extend our formula. Let's drag this to one more column. So this is the class probability. What is this representing? This is my 25p35 class, right? So here we multiply by this only. So again my annuity into 1 minus this, and class it is fixed for all. So apply the dollar sign here, bracket close, multiply by your probability of survival for female. So that is your probability of survival for female, and class the discounting factor, right? So class, we get this. Now again drag, control down, and alt equal to class. So class, this is my answer for EPV of benefit of annuity class. So class, is a very good question which was asked in your one of the exam class. Fine. So class, let's see the second part of the question. What it says: the company has now decided to allow for employees who leave the company, those who leave deemed to have a withdraw from the life insurance policy, and such their policy is cancelled, no further benefit are payable. The company has created a multiple decrement table based on the mortality and withdrawal rates experienced in its own portfolio over the last 20 years. So class, we have given the multiple decrements now. One is mortality, another is the withdrawal rate. The table of male life is given. So table is given. Now we have to calculate class independent rate of force of mortality and withdrawal implied by this multiple decrement table. Very important. We are given multiple decrement table class. With the help of this multiple decrement table, we have to find independent force of mortality and withdrawal. Fine. You may assume these independent forces are constant over each year age, and different forces are independent of one another. So class, we have given the force of mortality is independent, but the table is multiple decrement table. Remember this. Fine. Let's solve this question. So class, we have given two decrements. Able life is given, which can take the two decrement, withdrawal and death. And let us say this is my mu x w and this is my mu x d. Class, we have already seen independence of decrement, that is a mu x d, it is equivalent to mu x d, and a mu x w, it is equal to mu x w, right? This is we have already studied. Now from this multiple decrement, if we have to find mu x d, the formula is class aqxd divided by aqx into minus ln of apx, right? And class, similarly mu x w is aqx w divided by aqx into minus ln of apx, right class? We have seen this formula. And class, one more thing, what is aqx? Aqx is nothing but it is aqx d plus aqx w. Now class, quickly let's check the what is my aqx w. This is wx, although we have seen adxw divided by alx. So here this information is given as wx and this is given as lx. Fine. And similarly AQXD, it is nothing but dx divided by lx. Fine. So let's check in our Excel. So class, let's find out first AQXD. So class AQXD, that is dx divided by lx. Now control down, just take it to 4 decimal. Then similarly class AQXW, class WX divided by LX, same thing. Fine. Then class, let's find out AQX also, that make our calculation easy. What is AQX? That is sum of this plus this. Let's find out the APX also, that is 1 minus AQX. Now class, let's find out mu xd. Class, what is my mu xd? That is, we have formula AQXD divided by AQX into minus log of APX. Bracket close, enter, and class control down. Similarly, class mu xw, we can find out same formula, just this time we have AQXW in the numerator divided by AQX into minus log of class APX. Fine class. So these are my values of mu x, d and w. This is what independent force of mortalities we have to find in the first part. So class, next what it says. Now class, let's see the third part, what it says. It says the company has now decided to allow for employees who leave the company, those who leave deemed to have a withdrawal from the life insurance policy as such that their policy is cancelled and no further benefit are payable. The company has created a multiple decrement table based on the mortality and withdrawal rate experienced in the own portfolio for the last 20 years. The table for a male life is given in the sheet Q1. So class, this is the table which we have used earlier, that is having only one decrement, that is death. Now they are saying we have to use the two decrements, death and withdrawal. So once the person has withdrawn the policy, there is no benefit is given. Now what it says, calculate the independent force of mortality for a male life between 35 to 60, inclusive as implied by the table used in part 1 now. So class, we have to use the part 1 and we have to find the independent force of mortality, and then we have to calculate the adjusted independent rate of mortality and withdrawal rates for a male life. Fine. So class, in the first table, we have given only one decrement. The person is active and he may die. So this is the example of independent probability, right? And class, in independent probability, my mu x d, it is equal to what? Minus log 1 minus qxd. Fine. Plus a mu xw, it is equal to mu xw. So class, the withdrawal rate we will take from the second part and we'll find the mu xd of the first part. and then we'll find the revised probability. That is what they have asked. So let's see how to do this. So class, we have given for age 35 the male part. So male we have given, uh, so we have to find class QXD. So class QXD I am taking from age 35. This is given to us, male 35. So class, this is my probability, and we'll take till 60, 59 or 60, whatever you want to say. Fine. So class, this is my QXD. Let me, okay. Now class, we have to find revised mu XD. What is my revised mu XD? So revised mu XD will be, it is minus ln 1 minus QXD, right? Now select for all. Class, my revised mu xw remain same. Whatever my mu xw is here, this is my mu xw for 35, right? So it remain same. So it is J19. So I will write from J19. We get this values. Fine. So class, these are my force of uh, independent force of mortalities, revised independent rate of force of mortalities. Now with the help of this, we have to find the adjusted independent rate of mortality withdrawal for a male life, right? So when we have given mu, how to find the AQ class? So class, we have the formula for AQ XD. It is equivalent to mu XD divided by mu XD plus mu XW into 1 minus e to power mu XD plus mu XW. Plus this is the formula we are having. So apply this formula and get the value. So class, you get AQ XD. So this is my mu XD divided by mu XD plus mu XW into 1 minus e to power minus of this and minus of this class. Fine. So class, this is my AQXD. Similarly, class, we can find AQXW. Class, formula remains same. Just difference is here the numerator is mu XW first. Mu XW bracket this plus this into 1 minus exponential of minus of this and class this. Bracket close, close. Fine class. So we get this values. Now class, we can find the value of APX. That is 1 minus this and this. Fine. Now class, next part what is asked? He says determine the revised expected present value of lump sum benefit. Now lump sum benefit of 1, class, let's apply the formula here. Now class, we have two decrements. So what is my EPV of benefit now? Class, my EPV of benefit will be now 1 lakh V AQXD plus V square APX into AQXD plus V cube 2 APX into AQX plus 2D and so on, class, right? So let's apply this formula now to find the EPV of benefit, revised benefit. So class, first let's find out the discount factor, that is V. We have already taken V into the above value. So class, we have to take till 59, right? Now the EPV will be what, class? The sum assured S into discount factor into, okay class, we have to first one more thing we have to find. We have to find TAPX also. TAPX. So this is one into this value and goes till 59. Fine. Now we will find class EPV. So class, let's find out EPV. So class, EPV is what? Sum assured into discounting factor into TAPX into the probability of death. Fine. So select this, control down, class alt equal to. So class, now the benefit is 3324.57. Fine.